Hey everyone, welcome to another video, and in this video I'll be walking you guys through a problem that I made, and yeah, let's get right into it. So it says to solve for x, and one of the things that immediately caught my attention was this like expression over here, and this symbol just means that this pattern of root 2 root 2 root 2 just continues on forever and forever. Okay, so the way that this thing can be simplified is actually really neat. So let's say that this entire expression is equal to some value v is equal to root 2 on and on and on again. All right. So then let's take the square of v. If we square v, we will get 2 root 2 root 2 root 2 on and on and on nonstop. Well, if you notice, this part is the exact same thing as this part over here. So why can we not just substitute v right over here? When you do that, you'll get v squared is equal to 2v. Now we have a simple equation that we can just solve for the value of v. We can say v squared minus 2v is equal to 0. V times v minus 2 is equal to 0. And you get v is either equal to 0 or v is equal to 2. Well, if you notice, v equals 0 does not make sense over here, because the only way that v could equal 0 is that if we look back up here, this part over here would have to equal 0, which does not make sense for an infinitely square rooting number. This entire thing represents the geometric sequence that converges. However, it cannot converge on 0 because there still is root 2 times root 2 on and on and on and on, which will not give you 0. Okay, so we know that the value of this is just 2. So that is helpful. Let's substitute that in. So log 2 15 times 2 to the power of x minus 1 plus 16 plus 2 is equal to 2x. Alright, now let's get to solving. Let's subtract 2 on both sides. Get log 2, 15 times 2 to the power of x minus 1 plus 16 is equal to 2x minus 2. Now, in order to get rid of the log, let's just restructure this to say 2 to the power of 2x minus 2 is equal to 15 times 2 to the power of x minus 1 plus 16. Alright, now one thing I noticed is that 2x minus 2 and 2x minus 1 look really similar. And if I can manipulate this side to look like more like 2 to the power of x minus 1, we can set a variable for both of those terms and then solve that way. And the way I can do that is by rephrasing this into saying 2 to the power of x minus 1 times 2. And using our exponent properties, we can say that this is the same thing as 2 to the power of x minus 1 whole squared. And then this will just be the same thing. Now we can set some random variable, like d, equal to 2 to the power of x minus 1. And then when we do that, we can see d squared is equal to 15d plus 16. Now if we factor, we can get d, we rearrange, and then we can factor equals 0. Now if we factor, we can get d plus 1 and d minus 16 equals to 0. And you can then say d either equals -1 or d equals 16. One thing that we will know is that d when d equals -1 and hence 2 to the power of x minus 1 is equal to -1, this is actually an extraneous solution which will not work because no exponent will give you a negative number when the base is positive. So this is automatically an extraneous solution. So we can set 2 to the power of x minus 1 equal to 16. And we know that 2 to the power of 4 is equal to 16. So we can say 2 to the power of x minus 1 equals 2 to the power of 4. And then we can say x minus 1 is equal to, is equal to 4. And finally, we will get our answer as x equals 5. There you go. And that was a problem. I hope you guys enjoyed it. And let me know how you guys solved it yourself. And see you guys later.